All right, we are live. Welcome, everybody. Welcome back to Mr. Singh's Secondary Math 1 Honors class at Mountain Creek Middle School. Hopefully, y'all are getting settled and everything. I am slowly figuring stuff out. And hopefully, my quality of videos will be a little bit better. But first things first, I want to make sure that y'all are going onto Canvas. By now, you should be here. And if you go to modules, you'll see all the assignments posted. You can still retake work until next week, I believe. One more thing too, if you need a calculator, make sure you go on my front page over here where it says need a calculator. That looks like this right here. It's called the Wabbit Emu. You do that, download that, and that'll give you this kind of calculator. This is good for stats if you still need to make up stats work. Unfortunately, this only works on a Windows PC and a laptop. I don't think it works on Chromebooks. You have to check that for me. And it doesn't work on Mac, okay? But that's that for you. Another option is to go on Desmos. Desmos is available. Next thing is, if you go on modules, okay? And the very bottom of your modules, you should see online school. This is what we're using for the rest of the quarter and next quarter, okay? Look, if you can see here, I have week 1 retake sign up. You can sign up in there if you need to retake. You'll need to go on Canvas Conference with me. That'll be just on the top menu up here where it says conferences. Do you see that? And you just need to click on that and I'll invite you to it, okay? But you need to sign up first before I invite you. My times for retakes are Thursday, Friday between, I think it was 2 to 3 p.m. Think of it as like an after school thing, right? Other than that, I think that's it. But again, every day check Canvas. That's gonna be your friend, okay? I'll also send out announcements. There should be one as well if you log in and you go to announcements, okay? But let's get into the lesson. Okay, so today we are going to continue our geometry segment. This could be a lot of review for y'all. And again, feel free to skip around. That's totally fine as long as you're feeling comfortable in learning this. Please also get a piece of paper out and a handy calculator. You won't necessarily need one, but it's always good to have, right? I'm gonna use my Wabbit Emu here. And let's get to it. Okay, so do now. Again, this is going to tie into our lesson today, but let's just refresh our memory. Remember that the slope formula is going to be m equals y2 minus y1 over x2 minus x1, okay? So I had 2 points here. I need to find that slope. And remember, this will be our x1 right here. This is our y1, x2, y2. And we should be able to make our slope m equals 10 minus negative 5 all over 2 minus 3, okay? You should be able to simplify that. 10 minus minus makes plus, so we get 15 over negative 1. So my slope now looks like is negative 15, okay? That's our first part. Second part is write an equation line that goes through 2 points given. We're going to use point slope form for this, okay, for number 2. Remember, a point slope form is you need a slope and you need a point. Once you have those two things, you can connect it, and that should be your equation for number 2, right? So we have y minus y1. y1, I think I'll just use, let's just stick with what we're doing. We'll use negative 5 for y1, and that's equal to your slope, which is negative 15, parentheses, x minus your x1, which is 3. All right. Last step is to simplify. To simplify, we need y equals mx plus b, right? What does that y equal? And to simplify that, I'm just going to go ahead and start solving this. There should be an easy 2-step equation, but we got y minus minus makes a plus. So we got y plus 5 equals. Remember, what we need to do is we need to take this negative 15 and we need to distribute, okay? That's a huge, huge detail, right? So we got 15x. So negative 15 times negative 3 is going to be positive. I need my calculator. Let's see. So negative 15 times negative 3, that gives me positive 45, okay? Not too bad. Last step, you got to subtract. Go ahead and subtract those two. We get y equals negative 15x plus 40, okay? So you should be able to do this. This is highly important for today's lesson to understand all these concepts back from quarter 1, but we're going to start using it as part of graphing, okay? All right, so again, today we're learning slope, parallel, and perpendicular lines, okay? You should be able to identify 2 lines that are parallel or perpendicular or neither, and then write an equation for the ones that are parallel and write an equation for ones that are perpendicular. Should be a really easy lesson, and hopefully I'll try to get through this quick, right? So first things first, I want to check for number 1 and 2. I need to see if these two different equations make a parallel line, okay? So something to keep in mind, we can look in the bottom right of this slide, is that you can identify if lines are parallel by checking the slopes. All right, we will know if something is parallel by checking their slopes, that m value, right? Once we know that slope for parallel lines, okay, if you think about it, right, if my slope is going 2, and it's also the other second line is going 2, right? Do you have parallel lines? Do you see that? If I use my hand right here, there's those two lines, right? If I cross it, it's gonna be something else. But if you line them up, okay, it looks like it's gonna be a parallel line. So we know that two lines are parallel when the slopes are the same. Again, two lines are parallel when slopes are the same. Okay, so we say same slope, same slope is equal to parallel. All right. Okay, we'll do that, and let's go ahead and look at these ones. So number 1, I'm just going to do this a little bit quicker. I can see here my slope for the second one is m equals 2. Let's double check for this first one. Again, this is in point slope form, right? Y minus y1 equals m parentheses x plus x1. I can already see my slope is also 2. So we can say that these slopes are the same, and yes, those two equations are parallel to each other. Okay, let's do the same thing with the second one. A little bit weird, right? You got standard form, but no problem. What if I just subtract 2x to both of these sides for the second equation? I get y equals negative 2x plus 7. Looks like my slope is now m equals negative 2. Look at the first one. It's a little bit harder, but same thing. I need to get this into y equals mx plus b, okay? Remember, to do that, I need to first solve and get y by itself. So you should understand that you need to subtract 4x to both sides, right? You do that, you get 2y on the left. On the right side, you get negative 4x plus 14. And then what's the last thing I gotta do? You better say divide. Yeah, you gotta divide both sides by 2, right? Positive 2, that gives me negative 2x plus 7. That slope is equal to negative 2. Are those the same? Yes. That means those are parallel, okay? Let's try that again. Again, let's do this example. Go ahead and pause that video and try these. I want you to find out which ones are parallel to each other, okay? So again, pause that video and see what you got. Go ahead. Okay, hopefully you paused it. If you didn't, you are a pooper. Okay, let's look at the slopes of these. Again, I want to see which ones are parallel to each other. When they're parallel, the slopes are the same, okay? So looking at A, the slope is 3, right? You can look at this as y equals mx plus b, right? So the slope there is 3. With number B, letter B, it's negative 1 over 2, okay? So that's not the same as A, so that's definitely not going to be parallel. Let's look at this one, though. Remember, this one is in point slope form, right? So we have y minus y1 equals m parentheses x minus x1. What's our m there? Looks like it's 3 as well. Okay, let's just do the last one just to be sure. Again, I need to simplify this. I'll subtract x, get 2y is equal to negative x minus 4. Divide, right? Just 2 steps. We get negative 1/2 x minus 2. All right, double check again. What's the slope to that one? That slope is negative 1/2, okay? So it looks like A and C are the same, and then B and D are also the same slopes, meaning those are parallel, okay? Let me show you how to do this. So if you're trying to write the solution out, you can say that A, so equation A is parallel, those two big lines mean parallel, to C, and we could say B is parallel to D, okay? And that's it, right? You should be able to get that and hopefully feel good about it. Okay, let's do the next one. So now we're going to go into parallelograms. Remember, a parallelogram definition is right there, but that's when you have four sides, four-side shape with opposite sides parallel, okay? So remember, parallelogram is when you have parallel lines, okay? When you have connections there. If I was to draw some lines here, let's say A to B is your green, right? There's one. And then the second one, let's say it looks like it's D to C. That looks like it's parallel, but I need to double check that, okay? And we could check that by finding the slope. But then let's double check on A, D, and B, C. Let me use red. And I can also notice that those two also look the same. Those look parallel, right? But we're going to check those in a sec. Let me just set this up real quick, okay? So the red is going to be the vertical lines, and the ones that look very slopish diagonally, those are your A, B, and C, D, okay? So if we're checking those, I can do my rise over run, right? So if I was to go from A to B, I can check here that my rise is 1, 2. So 2, and the run is 1, 2, 3, 4, 5. So that's 2 over 5, right? Let's check DC. Same thing, point to point, D to C. We go up 2, and then to the right, 1, 2, 3, 4, 1, 2, 3, 4, 5, right? 2 over 5. So we clearly see that those are parallel lines from the naked eye, right? But if you find the slope, you'll see for sure, because the slopes are the same, they are parallel lines, okay? We could check for those same things, but what's going on here? Look at BCAD, right? If I was to check that slope, you have, you got your rise, 1, 2, 3, 4 for AD, for example, but the run is 0. Again, BC looks like it's the same thing. The run is 0. Rise is 4, run is 0, right? So what do we call that? Remember, we have the positive, we have the negative, we have the no slope, and then the 0 slope, right? No slope is going to be your vertical line. So we could say those are no slopes because you can't divide by 0, right? You could ask Siri on your iPhone, your fancy doohickey with that, and you'll see that you can't divide by 0 either, okay? So again, we could say that AD is perpendicular to BC because they are vertical and all vertical lines are parallel. Sound good? Hopefully you're feeling good about this. I think we're almost done. Easy peasy. Yeah, you know it. Okay, so perpendicular lines, all right? So just like we have perpendicular or parallel lines, now we could do perpendicular, right? Perpendicular is when they cross, and in that intersect is 90 degrees, right? Think of this as when you're driving, you're in that car intersection, right? That car intersection has 4 stoplights, ideally. That's your typical one. And those each, ideally as well, are 90 degrees from each other, right? Some of them's not, I understand, but the typical one's usually 90 degrees, okay? You can also see that with perpendicular lines, the two non-vertical lines are perpendicular if and only if the product of their slopes is -1, okay? Let's talk about that. If I look at the purple, does everybody see those two purple lines? Those are clearly perpendicular, but what I want to do is be able to check the slope of that, okay? So if I was to check the slope, hold on, my stylus is doing that thing again. But if I was to check my slope of those, all right, looks like I have a positive, looks like I have a negative slope. All right, let me fix it. Okay, so if I was to do the slope, I see that M here, my rise, looks like it's rising 2 over 3, okay? So notice how that's 2 over 3, but if I look at the other one, that one is going to be -3 over 2, right? -3 over +2. Looking at that, if I was to times those two together, take the product of them, -3 over 2 times 2 over 3, that is going to equal -6 over 6, which is -1, okay? When the two slopes multiply together, when you have the products of those two, you times them together, they get -1. That means they're perpendicular, okay, class? Notice how the horizontal line, the red line here, I'm going to do this in blue, right? Just that blue arrow. Notice how that's horizontal. The perpendicular one would be vertical, right? So if that's the case, when you have a 0 slope, the perpendicular line of that 0 slope would be a no slope, right? You got it, no slope, okay? Feeling good? Another idea to think about this is lines are opposite reciprocals to each other, okay? Going back, if I was to times those two, notice how one of them or both of them are opposite signs, and they're also opposite sides of the numerator and denominator, right? That numerator and denominator, they switch, and they also go negative, right? And when I do that, that's how you get that -1, class. So if I was to look here, lines that have the opposite reciprocal, meaning a negative with a reciprocal of each other, are perpendicular, right? An example of that, I'm going to highlight that, is 2 over 3. That's perpendicular to the opposite, which is negative. And then reciprocal is 3 over 2, right? So negative 3 over 2. Same thing with negative 4. The opposite of a negative is a positive, and then that's 4 over 1. So then the opposite or the reciprocal of that would be 1 over 4, okay? Let's just practice this again to just keep that momentum going. So if I have 2, well, the opposite of that is a negative, right? Knowing that's positive, and that's 2 over 1, so the reciprocal would be 1 over 2. Okay, class? 2 over 3, it would be negative 3 over 2. 1 over 5, negative 5 over 1, okay? Negative 3, now the opposite is a positive, so this is negative 3 over 1. The opposite would be positive 1 over 3, okay? Negative 1 over 4, well, the opposite of that would be positive 4 over 1. And what do you think about 0? Again, when we have a 0 slope, we got your positive, negative, no slope, 0 slope, right? Your 0 slope looks horizontal. Well, the opposite of that, or the opposite reciprocal, is your no slope, okay? So the opposite of that would be your no slope. All right? So hopefully that makes sense. Hopefully you feel good about it. We are almost done with this lesson, and let's keep that momentum going, okay? So now if I want to check again, if two lines are perpendicular to each other, what do I need to check? I just need to look at the slope, okay? What matters right now is the slope. And then we'll go on lesson 2 and look at some other stuff, okay? So look here. I can find my slope for these two equations. I got 3x plus y equals 5, and then negative x plus 3y equals 4, okay? Hopefully I'm not going too fast. I can go a little slower. Remember that we need to find the slope, we need y equals mx plus b. Oh, wow, I totally wrote that completely wrong. Remember, we need y equals mx plus b, okay, class? Don't be like me. Remember, y equals mx plus b. We got here minus 3x to both of those sides, right? This 3x plus y equals 5. So we got to find that y equals mx plus b. I'm just going to subtract 3x. So now y is equal to negative 3x plus 5. Same thing with the other one, negative x plus 3y equals 4. I'm just going to subtract. Well, actually not subtract. I'm going to add x to both sides, okay? So now you got 3y equals x plus 4. Divide, divide, divide. You get the idea. So now I got 1/3 x plus 4 over 3. Okay, remember the only thing I care about is that slope right now. Just for now, we're going to check it. So the slope here is equal to negative 3. Slope here is 1/3. Again, if we try to find the reciprocal opposite, well, are they both positive, negative? Yes. Is one numerator and denominator flipping from each other, right? If this is negative 3 over 1, does that switch from top to bottom, right? It looks like yes, too. And also we can check negative 3 over 1 times 1 over 3. Does that give you negative 1? Yes. So this, therefore, is perpendicular, okay? Now your turn again. Pause that video and try to see which ones are perpendicular to each other. Ready? Go. Okay, hopefully you should be done now. Again, you're probably not even pausing it. You're just skipping through this, aren't you? Anyways, let's check A. So A, we got x minus y equals negative 3. I'm just going to find that slope. Okay, I got to subtract both sides. Negative y is equal to negative x minus 3. Remember, there's a negative there, so I could either divide by negative 1 or times, either one. And that gives me y equals x plus 3. The slope there is 1, right? I'm going to do some blue. 2x plus 2y. Well, let's just solve for y. So we have 2y equals negative 2x plus 5. Whoops, let me write that better. And divide, divide. So y is equal to negative 1x plus 5 over 2. Okay, that's important. C looks pretty easy. The slope there is just 1/2. And then D, we'll just do it in red. How about that? We got 2y negative x plus 10. Divide, divide. Y equals negative 1/2 plus 5, right? Double checking, that looks right to me. All right, so let's talk about this, okay? You should be able to find your slopes. So we got m equals 1 for A, B is m equals -1, C is 1/2, D is -1/2, okay? So if I was to look at this and double check, I can see that, oh, well, 1, the opposite of 1 is -1, and since it's 1 over 1, you flip those around, it doesn't matter, right? But I can check that again, 1 times -1, that equals -1, so we're good there, right? So we can say A, we're gonna write this is perpendicular to problem B, okay? That's how we write it. That's the shorthand way. If I look at 1/2 and -1/2, right? Those technically are opposite to each other, but they're not reciprocal to each other, right? If I times them together, I get -1/4, not -1, right? So this is no, okay? Sound good? All right, we're almost done, right? So looking at this one, to wrap it up, I need to look at these equations, 1, 2, 3, and 4, and I need to find out what is the slope that is parallel, perpendicular to each given slope in each problem, okay? So if I was to look at that, well, number 1 and 2 is easy. That slope there is 2, so anything that makes it parallel. Remember, parallel means that the slope is going to equal the same, right? Perpendicular, we need the opposite. Opposite of positive is a negative. And since this is technically 2 over 1, we take the reciprocal of that, which is 1 over 2. Okay, and now look at the second one. That slope is -1 over 3. Perpendicular, we need to take the opposite. So the opposite of negative is a positive, and then that 1 and 3, they switch, right? They switch the denominator and numerator. So then your slope there for a perpendicular line is 3. You can say 3 over 1, but just 3, right? All right, pretty good, right? Look at number 3. Number 3, remember number 3 is y minus y1 equals m parentheses x minus x1. Again, I just want to worry about the slope for now, but you should notice that the slope here, this is in point slope form, but the slope is going to be 2 over 3, okay? Just right there, that's your slope, okay? Again, if I was to get the perpendicular line, I need the opposite. So opposite, this one's a positive, the opposite would be a negative. And then those numerator and denominators, they switch, right? They switch sides, so we get 3 over 2. That's it for that. Almost done, class. Do number 4. We got here x1, y1, x2, y2. All right, so then I do 3 minus 0 over -5 minus -1. Well, that's easy. 3 over, I'll just keep writing it out. How about that? Negative minus minus makes plus, so we get 3 over -4. So my slope there, class, is m equals -3 over 4. That's for a parallel line. If I was to do perpendicular, opposite is positive, and then you switch the numerator and denominator, right? So we got 4 over 3, okay? Feel good? All right, I think you're okay about that, right? Hopefully you're feeling good and going through this and probably even zooming through it. I don't know. Again, what we learned today, we learned to do parallel, perpendicular, and neither, determining from an equation. We were able to graph or make an equation with a line for parallel. We can make an equation for perpendicular, okay? Some things to keep in mind. Don't forget to comment in the discussion, right? Below is going to be a discussion. You need to comment at least once to get credit. Put a question if you want, and then I can answer that for you if you're confused. I understand I'm not the greatest teacher in the world, but this is all you got, right? Unless you want to use some other person on the internet. That's fine with me. I think, again, something you should work on today is your learning activity on Canvas. Watch part 2 video. That'll probably be maybe 20 minutes long, 30 minutes long. Who knows? Just skip through it or watch it through if you need help, right? Retakes. Keep in mind that you need to sign up for retakes. That is on Canvas in modules, okay? You will only retake if you sign up. I need to organize my class, right? And because of that, you need to be on top of things. If you're not, then sorry, I can't do anything about it. I got too much stuff to do, right? Yeah, even online school, I got a lot of stuff to do. Here's the fun part. If you want to get some extra help, if you have any questions, I will be doing a live stream on YouTube. Yes, I am going full gamer mode, but with math teaching, right? And maybe we could play some games on the side, maybe some cool math games or something, right? But office hours this week, we got Math 7. It's on Thursday, Friday. I'm at those times. But for you guys, make sure to stop by. I'll send out a link. On Thursday, I'll be available for Math 1, 12 p.m. to 1 p.m. And then Friday, 10 a.m. to 11 a.m., okay? If there's an exception and you want to, maybe nobody shows up, right? That's what I'm expecting. No one shows up, you can go on those 7th grade times. We could work some stuff out, right? But that is pretty much it, okay? So again, go ahead and watch video part 2 and check that learning activity out, all right? Good job.